Section 6.5, the conservation of mechanical energy, and Section 6.6, non-conservative forces and the work energy theorem. So first of all, we know that the total mechanical energy is equal to the kinetic energy plus the potential energy. So the formula is E, which represents mechanical energy, equals KE plus PE. And then we know that the non-conservative work is equal to the total mechanical energy final minus the initial mechanical energy. And we know that work is the difference between mechanical energies. In example 10, we ignored non-conservative forces such as friction. In reality, however, such forces are present when the roller coaster descends. The actual speed of the riders at the bottom is 45 meters per second, which is less than the determined in example 10. Assuming again that the coaster has a speed of 6.0 meters per second at the top, find the work done by non-conservative forces on a 5 kilogram rider during the descent from a height h0 to a height h final, where h initial minus height final is equal to 127 meters. So for this problem, we can use the equation that we saw in the section, which is the non-conservative force of work is equal to the final mechanical energy minus the initial mechanical energy. So if we expand this equation, we get that the non-conservative work is equal to 1/2 mv final squared minus the mass times the gravity times the height of the final value minus 1/2 mass times velocity initial squared plus the mass times gravity times height of the initial value. And then once we have that, we can plug in the numbers. So the non-conservative work is equal to 1/2 55, which is the mass, times 45 squared, which is the velocity, minus 6, which is m times g times h of the final value, minus 55 times 9.8 times 127, which is the mass times gravity times height of the initial value. And then we get the final answer that the non-conservative force of the work is equal to negative 1.4 times 10 to the 4th joules.